Welcome to this unit, Thinking in Models. This course focuses onto future thinking and future thinking mindset. Mapping the systems will be explained as a tool of creating scenarios. Now we are diving into the fascinating topic of thinking in models, specifically in the context of future scenarios and systems thinking. In a world filled with complexity and uncertainty, the ability to think in models is a valuable skill that allows us to explore and shape the future. By the end of this lecture, you will have a solid understanding of how to think in models and how it relates to future thinking and systems thinking. Let's embark on this journey of envisioning the future and creating alternative scenarios. System models. In a world of accelerating complexity and change, we see more and more that the tools we use to understand things not only fail to solve the persistent problems we face, but can also cause new problems. For example, we have experienced a very rapid industrialization since the Industrial Revolution in order to improve our individual quality of life. We are just now realizing that this industrialization is actually damaging the ecosystem we live in and threatening our future. Problems such as global climate change, ozone depletion, and air pollution have become a threat to our quality of life. Often, well-intentioned efforts to solve immediate problems produce unexpected side effects. Our decisions cause reactions that we did not foresee. We don't think much about what problems the solutions we put in place today may cause in the future. For this reason, we are creating an increasingly problematic future by always putting high costs on our future. There's a fundamental reason why we can't see the problems that the solutions we create today will cause in the future. Delay. Delay is when an action we take creates results after a certain period of time. Some causal relationships operate more slowly than others. Slow cause relationships in a loop determine the speed of the loop. Thus, there is a delay between cause and effect or system behavior. Time delays between the making of a decision and its effects on the future state of the system are quite natural and very common. Delays in feedback loops create oscillations in the behavior of the system. The oscillation of systems continues to affect the apparent discrepancies between the desired and actual state of the system, long after adequate corrective action has been taken. When building models, proven and evidence-based learning is required. In addition to generating insights throughout the modeling process, this approach also helps provide answers after the model has been created. The process of building a model often requires keeping these principles in mind. 1. Conceptualization basically requires some brainstorming and is usually a very creative process. In complex systems that cross organizational boundaries, this stage often leads to learning and new insights into how the system works or doesn't work. 2. Once we have agreed on the focus and scope of a model, the task of collecting data is required to create the model, which we usually define as a prototype model. 3. The development of the model requires people who know the system being worked on from the inside. Reliable models are provided by these people testing system behavior. Let's ask ourselves how a particular phenomenon, let's take the topic of sustainability, behaves. How has our company's sustainability charted over time? Over time, the increase in competition and the increase in costs created an unsustainable situation for our company. What is my purpose? Our goal is to reverse this pattern and develop a more sustainable business. 2. Create the model. What are the decisive loops in this regard? The first of the loops is the reinforcing loop created by sustainability trainings and sustainability activities. Our second loop is the balancing loop consisting of the variables of sustainability activities, employee resistance, and perceived threat. A careful eye will notice that there are one or more variables in common within these two loops. In our example, the sustainability activities variable is the common variable of both loops. In this case, when we put both loops together, the resulting pattern will look like this. This model is a model consisting of loops that reinforce and balance. 3. Start learning. After this stage, we can conduct various thought experiments on our model. What are the leverage points in this model? What would happen if we increased the training continuously and very intensively? How can we reduce employees' perception of threat? In conclusion, thinking in models is a powerful approach that allows us to explore the complex and uncertain terrain of the future. By defining alternative future scenarios using system models, we can better prepare for a range of possibilities and make informed decisions. In a world where the only certainty is change, this skill becomes invaluable in helping us navigate and shape the future. Thank you for your attention, and I encourage you to continue exploring the art of thinking in models in your personal and professional endeavors.